Hi, today we will be learning Eddy current. We know from before that when any coil, any conductor is kept in changing magnetic field or changing flux, then an EMF is induced in the coil in a direction such that it opposes a change in a magnetic flux. If flux is increasing, then the current induced will try to diminish the flux, and if flux is decreasing, the induced current will try to strengthen the decreasing flux. Now, if you have not such a wire and if you have a voluminous object and that is kept in any changing magnetic field or changing flux, in that case also you will find that an EMF is induced and current is produced in voluminous object, and that current is called eddy current. As the direction of form of the current is just like the whirling eddy that is formed in a river. You know, circular motion of water in deep river, that is called eddy, or bhavar also in India in Hindi. You would have seen tornadoes, typhoons in which there is circular motion of wind, air, that is just like swirling eddy. So the current formed in any voluminous object due to change of magnetic field line or due to change of flux is in the form of that swirling eddy. So the current is called eddy current, and this was discovered by Foucault, who has done a great job in light in the chapter light also. So what is eddy current? When there is change of a magnetic flux through a voluminous object, then a current is produced which has not a defined direction. Which the current takes the form of a swirling eddy so the current is called eddy current. As discovered by Foucault. Now this eddy current has great disadvantages. Suppose you have a core in any coil, in transformer or any electrical motor, an eddy current is generated. Then it will be disadvantageous in two ways. Firstly, the efficiency of the machine will be reduced. As some of the energy of the machine will be used in generation of electric current, and then this electric current, this electrical energy is further changed into heat energy. So when it is changed into heat energy, it wears and tears the machine. Sometime your machine may burn also. So these are the disadvantages. There are some advantages also. I will discuss you. Here you have a rectangular mesh of wire which is outside the magnetic field. So there is no current. Now as it enters the magnetic field, you can see that magnetic field lines increases through this rectangular wire mesh. So to just oppose the increase of magnetic field lines, it has created magnetic field in opposite direction. And a current is constituted in this rectangular mesh. Here you can see EMF is induced. And it will be flowing in a direction that can be obtained using right hand thumb rule. So if you place the thumb of your right hand along inside direction due to this cross, you will find that this charge should move in clockwise direction. Yeah, this is moving in clockwise direction. Field lines are increasing through this coil, rectangular coil, so charge is moving in anti-clockwise direction. Again here you can see. But once it enters into uniform magnetic field, now there is no change in magnetic flux or field. Always the flux is same, field is same at all these positions. Flux is same, field is same, so EMF cannot be induced. For production of eddy current or EMF, there should be a change of flux. Up till here there is no change of flux, uniform magnetic field is there. So now you have a change in flux. As the magnetic field is decreasing here, flux is decreasing. So a current will be induced, eddy current, so that it will try to strengthen the decreasing magnetic field, decreasing magnetic flux. Here you can see that field lines are in the same direction, just strengthening the pre-existing magnetic field which is reducing in magnitude. So when you apply here right hand thumb rule, then you will find the current is in anti-clockwise direction. Here again magnetic field lines, flux is decreasing, so current is there, the charge is moving all along this way anti-clockwise, current is there, but it has come out from the magnetic field, so there is no current now. I'll discuss that how this eddy current, where it is of disadvantage, can be reduced. So firstly I would like to show you some diagram. Here you have a strong magnetic field created due to north pole and south pole of a magnet, and a non-magnetic material like copper or aluminium, anything. I have taken copper. This is your copper plate. When it is made to move in this magnetic field, the number of field lines at the time of entering in the field increases. Number of field lines changes. Flux changes through this copper rectangular plane sheet. So a current will be induced, the eddy current. Now the direction of the eddy current will be such that it will oppose this increase of magnetic flux. So a magnetic field will be generated in opposite direction. Now you can find the direction of current using your right hand thumb rule. So if you place the thumb of your finger, right hand, in the direction of produced magnetic field, then fingers will curl in this direction, and this is the direction in which eddy current will be flowing. Now when it enters in uniform magnetic field, then you will find there is no change in magnetic flux through this copper plate when it is moving in uniform magnetic field. Now finally it tries to come out of the magnetic field. This time what happens? Here you will find that number of field lines is decreasing, and an EMF will be induced in this case, a current will be produced in this case, so that it will oppose the decrease in magnetic flux through it. And trying this, it will generate a magnetic field in the direction of pre-existing magnetic field, so that reducing flux should be strengthened. Now you can apply your right hand thumb rule. You can place your thumb in this direction in which magnetic field is created, and you will find that the direction of current will be in anti-clockwise direction. Here it was in clockwise direction, and when it is coming out, it is in anti-clockwise direction. So it will try to oppose increase in magnetic field line through it, and in trying so, it will speed down its velocity. So its velocity is reduced here, and while going out, again it will try to strengthen the magnetic field lines, the decreasing magnetic field lines. Here again, once the velocity of copper plate going out is reduced, so motion is damped at two places, and finally you will find that the motion dies out. So this is the example. This is how eddy current can be shown. Now this eddy current is disadvantageous in many cases. So we'll try to reduce this eddy current. You know that EMF induced as per Faraday's law and Lenz's law is equal to minus d phi upon dt. So EMF can be reduced, and the ways are, let me write the formula of flux. This is your AB cos theta. Now EMF can be reduced by decreasing magnetic field. That is not possible. By decreasing area of this plate, of the rectangular plate. Okay, this plate. This is possible. You can decrease the plate area by making slots in the plates. Here you can see slots are made in the form how slots are made on comb. You have cut the rectangular piece in many slots. So area has been reduced. Now second thing, if you make this angle 90 degree between area vector and magnetic field vector, here you have area and this is your magnetic field. So area vector and field vector is at 0 degree. But if the rectangular plane surface is in the plane of magnetic field, then you will find that area vector and magnetic field are at 90 degree, and EMF will be then reduced to 0. So these are the ways by which you can reduce eddy current, the EMF induced. First way is to reduce your plate area. This can be done by making slots in the plate. And second thing, the plane should be parallel to magnetic field, and the slots are in between the magnetic field and the plane. So in cores, here you have slots, and you can find that EMF is induced, current is produced in making small such loop. But by making slots, you can cut a strong EMF induced, strong eddy current. So in transformer cores, electric motor cores, are made of laminations. Laminations means flat stripes, fine stripes, rectangular stripes. Laminations are made of laminations and are kept parallel to magnetic field. And they are separated from each other from insulating materials. One such material is your lacquer. Many advantages too of eddy current. First one is your magnetic brake of a train. So when an electromagnet is activated in fast moving train, so eddy current is produced in the rails on which the train is moving, and that eddy current tries to diminish the increasing magnetic flux, and it will create a magnetic field just opposite to the increasing magnetic flux of the electromagnet of the train. So it stops the motion of train. And what is the very good thing is, there is no mechanical linkage between train and the rail. So this braking effect is very smooth. Now second one is electromagnetic damping. In galvanometer or in so many devices, you will find that when current flows and the needle starts oscillating, so we need its motion to be damped out very soon. And it is attained by eddy current created in the core of a galvanometer. Eddy current damps the motion very soon. Third one is your electromagnetic furnace. In electromagnetic furnace, the metal which we need to melt is kept wrapped under wires. And when strong current electricity with high frequency is flown through the wires, the eddy current is produced in the metal, and that eddy current increases temperature many-fold, and the metal get melted. You'd have seen in your electric meter also that there is a bright metallic object that moves in electric meter. in analog kind of electric meter, you can find it is moving, and that